In this lesson, we want to review operations with complex numbers. So in our last lesson, we reviewed the concept of the imaginary unit I. Again, the definition of I is given as I squared is equal to -1, or alternatively, you could say that I is equal to the square root of -1. So if we look at something like A plus BI, where we would say that A and B, these two guys are real numbers. And again, I represents the imaginary unit. When we see A plus BI, this is known as a complex number. Okay, so this whole thing together, we're going to say is a complex number. Now, in your textbook, when you see something written as A, some real number, plus B, another real number, multiplied by I, again, the imaginary unit, this is known as standard form for a complex number. So something like 3 plus 7i, or something like -2 minus 9i, right? So on and so forth. This is in standard form. You want the real part, which is this part right here. So this is the real part, because it only consists of a real number. And then this part right here, this BI part, is last. This is your imaginary part. So this is the imaginary part. Now, some textbooks will differ on this. They'll only call B the imaginary part. So you just need to be aware that from textbook to textbook, from teacher to teacher, they might say something different. But generally just go with whatever your teacher or your textbook is saying. Okay, so it's either that BI is the imaginary part or just that B is the imaginary part. Now, when we work with complex numbers, we need to understand that the real numbers are a subset of the complex numbers. What do I mean by that? Well, I can take any real number that I want and write it as a complex number. Let's say I had the number 3. I could put this as 3 plus, for my B there, I'd use a 0, and then times I. 0 times anything is always 0. It doesn't matter if I'm multiplying it by I. It's the same. So this would be just 3, right? I'd have 3 plus 0, which is just 3. So I took a real number 3, and I wrote it as a complex number, 3 plus 0i. So again, that tells us that the real numbers are a subset of the complex numbers, right? They're part of them. As another example, I could take something like -16, and I could write it as -16 plus 0i. And again, this is just -16. This is the same thing as when we took integers and we showed that we could write them as rational numbers. Because we could say all integers are rational numbers, right? So if I took, let's say, -12, I can always write this as -12 over 1, and this shows it as a rational number. But not all rational numbers are integers. I can't take something like 2/3 and write it as an integer, okay? So it's the same concept here. All real numbers are complex numbers. You can write them as plus 0i. So 3 plus 0i is 3. -16 plus 0i is -16, so on and so forth. But not all complex numbers are real numbers, okay? The complex numbers include more numbers, okay? They're a larger set. So I could do something like 2 plus, let's say, 5i. This is a complex number. I cannot write this as a real number. So when we work with complex numbers, we use the same properties to simplify things. So if I saw something like the quantity -3 plus I, then plus the quantity 2 plus 5i, I would just arrange the real and the imaginary parts together. So in other words, I would use my associative and my commutative properties to kind of reorder this. I could say this is -3 plus 2. Those are the real parts. Then plus, you have I plus 5i. I plus 5i, those are the imaginary parts. So we could say -3 plus 2 is -1. And then plus, you have I plus 5i, which is 6i. So you end up with -1 plus 6i as your answer here. And notice how we give our answer in the format of A, the real part, plus your B, which is 6 in this case, times I. Okay, this is the imaginary part. This is the real part. So this is your standard form, right? Some people will kind of switch this around and say this is 6i minus 1. This is not standard form, okay? You want the real part first. That's why we have -1 out in front. Then plus your imaginary part, the 6i, second. All right, let's take a look at another one. So suppose we had the quantity 8 minus 3i, then minus, we have the quantity 2 plus 4i, then minus, we have the quantity 2 plus 6i. So what I want to do here, let me just distribute the negative to each term. I'm going to put plus negative 1 here and plus negative 1 here. So I'm going to write this as 8 minus 3i. Then negative 1 times 2 is minus 2. Negative 1 times 4i is minus 4i. Negative 1 times 2 is minus 2. Negative 1 times 6i is minus 6i. So we can regroup these if you want. At this point, you should understand that you can add the real parts together and the imaginary parts together. So in other words, I can say 8 minus 2 minus 2. 8 minus 2 is 6. 6 minus 2 is 4. But if it helps you, you can group it like this. 8 minus 2 minus 2. And then plus, you've got your imaginary parts. So you've got your negative 3i. You've got your minus 4i. And you've got your minus 6i. If you need to group it like this for a while, that's fine too. It's just a little bit slower. So again, 8 minus 2 minus 2 is 4. So that's your real part. Then plus, negative 3i minus 4i is negative 7i. Negative 7i minus 6i is negative 13i. So let me just put minus 13i. And again, it's written in standard form where your real part is first, your 4. This is your A. And then you have plus. In this case, you'll have negative 13 that represents your B. And then you have I. So this part right here is going to be your imaginary part. So the real part comes first. Imaginary part is second. All right, let's look at some multiplication problems. Pretty simple to do this. We're just going to use our FOIL method because we have the product of two binomials. So we have the quantity 6 plus 6i times the quantity 4 plus 6i. All I'm going to do here, first term, 6 times 4 is 24. My outer terms, 6 times 6i is plus 36i. Make that a little better. Then plus 6i times 4 is plus 24i. And then last, 6i times 6i is plus 36i squared. Okay, so what can we combine? The 24, I can't do anything with that for right now. We'll be able to do that with something with it in a second. But for right now, nothing. 36i plus 24i. 36 plus 24 is 60. So this would be plus 60i. And then 36i squared. Remember, I squared is defined to be negative 1. So I can go ahead and say this is plus 36 times negative 1, which is basically minus 36 or negative 36. So I can erase this and put minus 36. And now I can combine 24 and negative 36 as negative 12. So I want the negative 12 out in front, because that's the real part. Then plus, I want the 60i in the back, because this is the imaginary part. So negative 12 plus 60i is your answer in standard form. All right, let's take a look at a longer one. So we have the product of three binomials here. So I'm going to use FOIL with the first two, and then I'll take that result and I'll multiply it by the final binomial. So we'll just start with these guys right here. So what does that give us? So 5 times negative 6 would be the first terms. That's negative 30. The outer 5 times 6i is plus 30i. The inner 3i times negative 6 is minus 18i. The last 3i times 6i is plus 18i squared. Now, we know I squared is negative 1. So let's go ahead and erase this and put a minus 18. So to combine things here, negative 30 minus 18 is negative 48. So negative 48. Then we know that 30i minus 18i is going to give us 12i. Okay, so let's erase this. So we're going to put this in parentheses, and we'll drag it up. And now it's times this guy, negative 1 minus 3i. Okay, so let's do the FOIL again. So negative 48 times negative 1 is positive 48. Then negative 48 times negative 3i is plus 48 times 3 is 144, and then times I. Then you'd have 12i times negative 1, which is minus 12i. And then lastly, you would have 12i times negative 3i. That's minus 36i squared. And make that a little better. All right, so let's wrap up the problem now and do some simplifying. We know that I squared is negative 1. So if I had a negative 1 times this negative here, this would become positive, okay? So 48 plus 36 is 84. So this is 84 plus 144i minus 12i is 132i. So again, our answer here in standard form is 84 plus 132i. All right, so let's talk a little bit about dividing with complex numbers. you need to be aware that, again, the definition of I is that it's equal to the square root of -1. So if I have -7 over 5i, this is really like saying I have -7 over 5 times the square root of -1. We know that a simplified radical expression does not contain a radical in the denominator. So we want to rationalize this guy. And so we can multiply both the numerator and denominator by the square root of -1. But typically what we'll do is just keep it in this format of I. So I'll do I over I, right? So in the numerator, I'll have -7i. In the denominator, 5 times I is 5i squared. We know I squared is -1, so this would basically be what? -7i over -5. Negative over negative is positive, so you end up with 7i over 5. Now, it's okay that I is in the numerator because, again, you can have a radical, the square root of -1, in the numerator. You just don't want it in the denominator because it's not considered simplified. All right, let's take a look at another one. So we have 9 plus 4i over -5i. Again, I've got I here in the denominator. So to get rid of that, I'm going to put I over I here and multiply by that. So I've got to use my distributive property. I times 9 is 9i. Then plus 4i times I is 4i squared. And we know that's -1. So you can go ahead and just replace that and say this is negative. Okay. Anytime you get I squared, just immediately replace it with -1 and see what that gives you, because you don't want to have to worry about simplifying it later. It might be something you just forget. So then down here, -5 times I times I times I is I squared. So the -5 times -1, right, that's I squared, would give me +5. So there's really nothing else I can do to simplify here. You'd just be left with 9i minus 4 over 5. If you wanted to, for the sake of writing this in standard form, you could reorder this. First, you could break it up as 9i over 5, then plus -4 over 5. And then you want the real part out in front. So you would go ahead and say this is -4/5, that real number, then plus your imaginary part, which is going to be the 9i over 5. So again, if you wanted to write this in standard form, you would want to break it up like this. You've got your real part of -4/5 plus your imaginary part of 9/5 times I. All right, so the last concept we're going to go over is basically rationalizing with a binomial denominator that includes a complex number. All right, so we previously learned that conjugates were the sum and difference of the same two terms. So something like the quantity a plus b times the quantity a minus b. So you've got a and a, you've got b and b, different signs, right? Plus and minus. If we were to FOIL this out, the middle two terms drop out. You've got a squared minus b squared. Okay, so nothing new there. When you do this and you have I involved, like a plus bi multiplied by a minus bi, the sign is going to change. It's because you're going to end up with an I squared, and the I squared is -1, and so it flips the sign. So first terms here, a times a is a squared. Your outer, a times -bi is minus abi. Your inner, a times bi is plus abi. You can see those would cancel, right? They're basically opposites. You've got minus abi and plus abi. You can erase that. You don't need it. Then we've got positive bi times negative bi. We know that's a negative. B times b is b squared. And I times I is I squared. Okay? We know I squared is -1. So if I replace this with -1 here, again, you can think about this as plus a negative here. Negative times negative is positive. So this is going to be a squared plus b squared. Okay, so that's where that comes from. So we're going to use this part right here to help us simplify a two-term denominator when I is involved. So let's look at an example we already know how to deal with. So if we saw something like 8 over, you have 3 minus the square root of 5. We should know at this point that if we have a binomial denominator here, we can multiply the numerator and denominator by the conjugate of the denominator. So I would just multiply by 3 plus the square root of 5 over 3 plus the square root of 5, right? This is going to clear my radical from the denominator. In the numerator, 8 times 3 is 24. Then plus, you'd have 8 times square root of 5. In the denominator, 3 times 3 is going to give me 9. So then the outer and inner would cancel. You'd have 3 times square root of 5, and then negative 3 times square root of 5. So those would cancel. And then lastly, you would have minus. We know the square root of 5 times square root of 5 would be 5. So let's finish this up. We would have 24 plus 8 times square root of 5 over 9 minus 5 is 4. Now you can simplify this further because you can factor out a 4 from the numerator. So if a 4 got factored out, inside you would have a 6 plus 2 times square root of 5. And this is over 4. I can cancel this with this, and I'd be left with a simplified answer of 6 plus 2 times square root of 5. Now, we're going to use the same thought process for this example here. So we have 9i over, you have negative 5 minus 7i. So I want to get rid of this guy right here because it represents a radical of square root of negative 1 in the denominator, okay? So what I'm going to do is I'm going to multiply the numerator and denominator by the complex conjugate. So it's the same concept. So I'm going to take this guy right here, the negative 5. I'm going to take this guy right here, the 7i. I'm just going to flip the sign. So it's negative, it's going to become a positive, right? If it's subtraction, it becomes addition. If it's addition, it becomes subtraction. Okay, that's all you're doing. So over here, I have the same thing, negative 5 plus 7i. And what happens is when I multiply, in the denominator, I don't need to go through FOIL. I just showed you that if you have a minus bi times a plus bi, it's a squared plus b squared, okay? So a is negative 5. If I square that, I get 25. Then plus b is 7, okay, and 7 only. If I square 7, I get 49. And you can pause the video and verify that for yourself, but that is what you get. Remember, I times I is I squared, and that represents negative 1. Okay, so that's why you get a different sign. In the numerator, 9i times negative 5 is negative 45i. Then we have 9i times 7i. That would be plus 63i squared. Okay, let's see what we can do to simplify. Well, we know I squared is negative 1. So I'm going to start out by just writing this as negative 63. And then minus 45i. And this is over. 25 plus 49 is 74. Now, is there anything at this point that I could cancel? So I would have to be able to pull something out from this and this that could cancel with this. Okay, so there's really nothing else you can do. But we do want to split this up and say this is negative 63 over 74. And then I'm going to say plus, you have negative 45 over 74 times I. Again, this part right here, your negative 63 over 74 is the A, or the real part. And then this part right here, this is your B, right? Your negative 45 over 74, and then you have your I. So you've got your real part and your imaginary part. Again, the real part goes first. That's how you put it in standard form. So negative 63 over 74 plus negative 45 over 74 times I. All right, let's take a look at one more of these. So we have 6 minus 6i over, you have 2 plus 3i. Again, the idea is I want to get rid of this I in the denominator because it represents a radical in the denominator. So this is not currently simplified. All I need to do is multiply the numerator and denominator by the complex conjugate. So 2 and 3i, just change the sign. Right now it's a positive or a plus, so you could say this is going to be a negative or a minus. Okay, so 2 minus 3i. All right, so now we just do our multiplication. Again, just use the formula down here, it's faster. If I had 2 plus 3i multiplied by 2 minus 3i, again, it's a plus bi times a minus bi. Okay, so it's a squared plus b squared. Okay, 2 is a, 2 squared is 4. Then plus 3 is b, 3 squared is 9. We know 4 plus 9 is 13, so let's just go ahead and write that. So the denominator's done, we don't need to do anything else. In the numerator, we've got to use our FOIL. Okay, so we've got 6 times 2, that's 12. The outer would be minus 18i. The inner would be minus 12i. So let's go ahead and combine that. We know that would be minus 30i. And then for my last, I would have a negative 6i times a negative 3i. We're going to go ahead and say that's a plus. 6 times 3 is 18. And then we would have I times I, which is I squared. Now we know that I squared is negative 1. So that would be negative 18. So we can basically say this is minus 18. And then 12 minus 18 is negative 6. So let's go ahead and erase that and that. And let me erase this and say this is just negative 6 minus 30i over 13. Again, to put this in standard form, I'm going to break it up. I'm going to say this is negative 6 over 13. Then I'll put plus, you'll have negative 30 over 13, and then times I, okay? So this is your real part. This is the A. This is the B part, okay? This is what's multiplying I. But the whole thing, the negative 30 over 13 times I is the imaginary part. But again, some books go back and forth on this. So standard form, I'm just going to say, is negative 6 over 13 plus you have your negative 30 over 13 times I.